Have you ever wondered why dwarf galaxies, despite being predicted to have numerous satellite galaxies, seem to be missing quite a few of them? This is the enigma we're about to unravel. Welcome to the mystery of the missing satellites of dwarf galaxies, a conundrum that continues to puzzle astronomers and cosmologists alike. Each tiny, elusive dwarf galaxy we peer at through our telescopes should be surrounded by a swarm of even smaller satellite galaxies. Yet, as we gaze into the vast cosmic wilderness, we find an unsettling void. The expected numerous satellites are conspicuously absent. Why does this matter? Well, these missing satellites hold the key to understanding galaxy formation theories. They are the pieces of a cosmic jigsaw puzzle, which when put together can offer us a picture of how galaxies, and indeed the universe itself, came into being. Let's delve into the top 10 theories that try to solve this cosmic mystery. The first theory points towards the unseen and the mysterious, dark matter, a concept that's as elusive as it is intriguing. Dark matter, despite being invisible to our eyes and telescopes, is believed to make up about 80% of the matter in our universe. Imagine that, an entity we can't see, yet it holds such sway over our cosmos. Now, how does this relate to our missing satellites? Well, the theory suggests that these unobserved satellites are composed majorly of dark matter. They're there, but we can't see them because our tools are not equipped to detect dark matter. We're like detectives, trying to solve a mystery with only half the evidence available. Dark matter's gravitational pull plays a pivotal role in galaxy formation, binding galaxies together. It's like the unseen glue holding the universe in place. Could unseen dark matter be the answer, or is there more to the story? The second theory suggests that it's not a case of missing satellites, but rather a case of observational bias. Now, what does that mean? It means that our perception of the universe might be skewed by the limits of our tools and techniques. We're like detectives, peering through our cosmic magnifying glass, trying to count the number of satellite galaxies around dwarf galaxies. But what if our magnifying glass isn't big enough or clear enough? What if we're missing out on the faintest, most distant satellites simply because they're too hard to spot? This observational bias could lead to an undercounting of satellite galaxies. If this is the case, then the satellites aren't missing at all. We just haven't found them yet. It's like looking for a needle in a haystack, but the haystack is the universe, and the needle is a galaxy. But is it really just our limited perspective, or is there an actual discrepancy? The third theory takes us into the heart of galaxies, where tidal forces reign supreme. You see, galaxies are not just collections of stars and planets, they are gravitational symphonies, with each celestial body exerting a pull on every other. This constant tug-of-war creates what we call tidal forces. Imagine a smaller satellite galaxy approaching a larger galaxy. The side of the satellite galaxy that's closer to the larger galaxy experiences a stronger gravitational pull than the far side. This difference in gravitational attraction can stretch and distort the smaller galaxy, like pulling at a piece of taffy. Over time, these galactic tidal forces could disrupt and even completely dissolve smaller satellite galaxies, effectively absorbing them into the larger galaxy. These tidal forces are a galactic ballet, a dance of destruction and creation, constantly reshaping the universe around us. So, when we gaze up at the night sky and wonder, where are all the dwarf galaxy satellites? We have to consider this. Could these cosmic forces be the culprits behind the missing satellites? If you're enjoying this journey through the cosmos, don't forget to take a moment to engage with us. You can do this by subscribing to our channel. We regularly delve into fascinating mysteries like this one. By subscribing, you'll always be in the know when we release a new video. If you're finding this video informative and interesting, give it a thumbs up by clicking on the like button below. Your likes help us understand what content you enjoy, and they also help more space enthusiasts find our videos. Now, we want to hear from you. What do you think about these theories? Have you got a theory of your own? Leave a comment below. We love reading your thoughts and learning from your insights. Now, let's buckle up and dive back into our exploration of the missing satellites. The fourth theory takes us back to the early universe, during a period known as Reionization. Now, imagine the universe as a dark, dense fog, with the first stars and galaxies struggling to shine through. Then, over hundreds of millions of years, their ultraviolet light starts to ionize the fog, breaking down hydrogen atoms into protons and electrons. This is reionization, a cosmic shift that allowed light to travel freely through the universe. But what does this have to do with our missing satellites? Well, these dwarf galaxies were forming in the midst of this reionization period. The intense ultraviolet radiation could have heated the gas within these embryonic galaxies, making it harder for them to pull together and form stars. Thus, many potential satellite galaxies may have remained dark, invisible to our telescopes. So, could it be that these missing satellites are not missing after all, but simply hidden in the shadows of cosmic history? Could the early universe hold the key to this mystery? The fifth theory brings us back to dark matter, but this time focusing on its interactions. Now, we know that dark matter doesn't interact with light, but what if it interacts with normal matter in ways we don't yet understand? The idea here is that dark matter might be able to interact with the normal matter found in satellite galaxies. This could cause a sort of gravitational friction, leading to a loss of energy from the satellite galaxies. With less energy, these galaxies could spiral inwards, merging with their larger host galaxies over time. This process, often referred to as dynamical friction, could explain why we see fewer satellite galaxies than expected. The missing satellites might not be missing at all. Instead, they could have been swallowed up by their host galaxies, their stars now a part of the larger galaxy's stellar population. Could the interplay of dark and normal matter be the missing piece of the puzzle? Let's quickly round up the remaining theories from 6 to 10. First up, we have the galactic cannibalism theory. This suggests that larger galaxies may have swallowed up the smaller satellite galaxies that once existed. This theory, while gruesome in its terminology, is a fascinating possibility and is supported by evidence of galactic mergers in the cosmos. Moving on, we have the primordial black holes theory. This proposes that primordial black holes might be responsible for the disappearance of these satellites, either by consuming them or by disrupting their structure. Next, we have the quantum fluctuations theory. This theory suggests that quantum fluctuations in the early universe might have played a role in the formation and subsequent disappearance of these satellite galaxies. It's a bit more abstract, but remember, in a universe as wide and mysterious as ours, even the abstract can be plausible. Next up is the multiverse theory. This one is a bit of a stretch, but it suggests that these missing satellites might exist in other universes. It's a mind-boggling concept, but it's a theory that some cosmologists are seriously considering. Finally, we have the simulation hypothesis. This theory proposes that we live in a simulated universe and the missing satellites are simply not part of the program. It's a controversial theory, but one that is gaining traction in some scientific circles. All these theories, from galactic cannibalism to quantum fluctuations, from multiverse theory to simulation hypothesis, offer unique perspectives on our quest to understand the missing satellite problem. Each one tests the boundaries of our knowledge and comprehension, pushing us to think beyond the confines of our current understanding of the universe. It is this spirit of inquiry and discovery that drives the scientific endeavor. These theories, while not as prominent, still provide intriguing possibilities. Now that we've explored the top 10 theories, let's reflect on why this mystery matters. The missing satellite problem is not merely a conundrum for astronomers to solve, but a puzzle that could potentially reshape our understanding of the universe. It challenges the very foundations of our knowledge about galaxy formation, and in doing so, opens up a world of possibilities. At the heart of these theories is the role of dark matter. The invisible substance that constitutes about 85% of the matter in the universe is a key player in these theories. It's like the unseen puppeteer, pulling the strings and dictating the dance of galaxies. If dark matter indeed influences the formation and distribution of satellite galaxies, it will confirm its fundamental role in shaping the universe. Alongside, these theories also bring to light the possibility of observational bias. The universe is vast beyond comprehension, and our view from Earth is limited. Perhaps we are not seeing the whole picture. This perspective calls for more advanced observational technologies and methods, pushing us to take giant leaps in space exploration. The theories also touch upon galactic tidal forces and reionization, aspects that delve into the dynamic nature of galaxies. They paint a picture of a universe that is not static but constantly evolving and interacting, where galaxies are born, grow, and are torn apart by the very forces that created them. Lastly, the missing satellite problem is significant because it keeps us humble. It's a stark reminder that despite our technological advancements and scientific progress, there's still so much we don't know about the universe. We are but a small part of this cosmic dance, trying to decipher the steps. As we continue to explore the cosmos, the mystery of the missing satellites serves as a reminder of how much we still have to learn. So, let's keep looking up, keep questioning, and keep exploring, because every mystery solved unveils a new one. And that's the beauty of the universe.